Hey guys, it's Miss Miller. Let's talk a little more about acceleration. Now, I know I have already swamped you with acceleration equations and more acceleration derivations of those equations, but now your toolbox is full. Now you have a big bunch of equations that we can use at any time. So to just put our toolbox together, let's go ahead and clear that off. Let's talk about equations you use when we have a constant velocity. Now, last unit, some of y'all had some questions about, velocity and speed. Yes, those can be used interchangeably. The only difference is you can have a negative velocity, for example, if you're moving left, but you can't have a but you can't have a negative speed. Okay, speed is just the value, the number associated with the velocity, whereas the velocity is the change in your position over change in time. Speed would be just a distance over time, so it cares about the path that you take. Now, if you're undergoing a constant velocity, the only equation you have is delta x equals your velocity times your time. However, if we have a constant acceleration, we have a couple more equations that we can look at, and I've already listed them for you. We have acceleration equals the final minus the initial velocity over a change in time. Okay, I want to just call t change in time, all right? The second equation is delta x equals your initial velocity times time plus 1/2 your acceleration times your time squared, and then the third equation is your final velocity squared equals your initial squared plus 2 times your acceleration times your displacement. Remember, delta x is displacement. Now, I do want to give you a special equation. It's not used very often. However, if you are undergoing constant acceleration, then this equation is true. Your average velocity occurs at the middle time, okay? Right in the middle of everything. So your average velocity is going to be a mathematical average of your initial and final velocity if you are moving at a constant acceleration. So let's start working some examples. Then you'll have just a couple to do on your own. You will need to study those examples that I give you because you'll have a test at the end of the week. So let's get started. Another note that I need to give you. Let's talk about Freefall just a little bit. Freefall has a special acceleration due to gravity. I think we've already talked about that. I'm going to put g equals negative 9.8 meters per second, okay? That is your acceleration due to gravity, given that you have an object in free fall. Now, all of that being said, this is my toolbox. This is all the equations, or these are all of the equations that I have to work with to solve problems. Okay, let's start with this one. A poorly tuned car accelerates from rest. That from rest means something. To a speed of 28 meters per second in 20 seconds. What's the average acceleration of the car? How far does it travel in this time? So first, I always start problems by drawing a picture, if I can. So in this case, we have a car starting at rest. So that tells me my initial velocity is 0. We're starting at rest. I'm just going to put a dot there to indicate I'm not really moving. And we're moving at a speed, or we're increasing our speed to 28 meters per second. So since I'm increasing my speed, let's just say my speed here is a final speed of 28 meters per second. Since I am accelerating, I know I'm going to use my acceleration equations. And we know the time that all of this takes place over is 20 seconds. So I'm given quite a bit. Initial velocity, final velocity, and time. So let's go ahead and solve the problem. It's asking what is the average acceleration. Okay, well, I'm going to go to my equation for acceleration. Look at the first one. I have my final, I have my initial, and I have my time, so I'm just going to plug in those numbers. 28 minus 0 over 20 seconds is going to be 28 divided by 20. 1.4 meters per second, because our units for acceleration, units for velocity are meters per second. Units for time are seconds, so meters per second per second. So there's the first part done. Now, how far is asking what? Well, it's asking us to find delta x. So I'm going to look at my toolbox of equations. I would suggest that while you're watching this video that you have your toolbox out, okay? Copy down those equations. Go ahead and do it now. Pause the video so that way as we go through these examples you have it. I'm going to use the delta x equation. Now that I know acceleration, I know time, I know an initial speed, I'm golden to solve these problems. Delta x equals 1/2 my acceleration, 1.4. Now, here is where you have to be careful. Remember I told you there were cases where acceleration was positive or negative. In this case, it's going to be positive because I am speeding up to the right. That is a case for positive acceleration. 1/2 a t squared. What is my time? My time is 20 seconds. So 20 squared plus my initial speed. Well, if I start from rest, my initial speed is 0. And in some problems, if it doesn't give you an initial speed, you have to think, does it make sense for my initial speed to be 0? And in a lot of cases, it does. This is what we're solving. 1/2 times 1.4 times 20 squared, or 400, 280. Oh goodness, my pen. Now, 0 times 20 is 0, so that side basically goes away. So delta x is 280 meters. All right. At t equals 0, a car has a speed of 30 meters per second. After 6 seconds, its speed is 15 meters per second. Find the average acceleration. So here, I'm going to write what I know. T equals 0 seconds. VI, look, it has a speed of this, and that's the first speed it's given me, so I'm just going to make the assumption that's my initial speed, 30 meters per second. My final velocity, 15 meters per second, because that's after I have done the accelerating. Oh, why did I put 0 here? That was goofy. I accelerate for 6 seconds. Sorry, guys. That should be a 6. Find the average acceleration. Come on now. Look at your toolbox. VF minus VI over T. We have every single thing that we need to solve for acceleration. VF is 15. VI is 30. Time is 6 seconds. So if we do 15 minus 30 divided by 6, we're going to get negative 2.5 meters per second as our acceleration. Now, what does that negative mean? Okay, well, first of all, we're slowing down. Okay, remember I said if you're slowing down, something has to be going against you. So if we're moving to the right in a positive direction, okay, think of a coordinate plane. Okay, right is positive and up is positive. If I'm slowing down in a positive direction, something is pushing against me, okay, to cause me to slow down. So that means my acceleration has to be in the opposite direction. So that's negative. Notice, even with my calculations, it's negative. All right, I'm going to do one more example. Maybe 2. Okay, let's look at this one. This one's where you have to be careful. We have a building that is 30 meters tall. Go ahead and read the problem on your own. So I'm going to write what I know. We're dropping it, so I make the assumption that my initial speed is 0 meters per second. Now, if I start here and it falls down 30 meters, my delta x, my displacement, okay, my change in position from where I start, is going to be a negative 30 because I moved down 30 meters, and down is negative. Now, this object, this rock, is going to be in free fall. So if that's the case, I know that my toolbox says if an object is in free fall, then the acceleration due to gravity is a negative 9.8 meters per second per second. So that's good. Determine how fast. So how fast asks me to find a velocity. I'm looking for that velocity. And I don't have a time. So I need to look at my toolbox for an equation that deals with time, or that doesn't have time in it. Okay, my equation with time in it is VF squared equals VI squared plus 2A delta X. So we're going to solve for VF in this case. How fast? That's what it's asking for. Basically, it starts at 0 and it increases its speed as it goes down. And then finally it hits the ground at some final velocity here, and that's what we're looking for. So VF squared equals our initial velocity squared. Our initial velocity is 0. Plus 2, my acceleration is negative 9.8, times delta x, which is negative 30. Now guys, if you would have forgotten that delta x should be negative, your calculator would say, oh crap, I cannot take the square root of a negative number. Okay, that's why it's so important to remember that this is negative and that the acceleration due to gravity is negative. But regardless, we have VF squared equals, I want to simplify this. Let's see. Oh gosh, where's my calculator? Here it is. So 2 times negative 9.8 times negative 30. 588. Now, to get the VF squared by itself, you have to take a square root. That basically gets that 2 in the exponent gone. So I'm gonna, that goes away, and VF is left as the square root of 588. Now remember, it's a velocity, so our units are going to be meters per second, but our velocity is going to be 24.2 meters per second. Now some of you might say, Miss Miller, how many decimals do you want me to go? So my calculator says 24.2487, and I could keep going. Please don't give me calculator vomit, okay? Notice, it gave me 30 meters. If you know anything about sig figs, and I don't require that you do, but that's 2 sig figs. So please only give me like 2 or 3 digits in your answer. I don't want 24.2863975, just on and on and on. That's not cool. Okay, that's called calculator vomit, and I don't like it. Alright guys, I'll probably post another video doing more examples just because these problems aren't fun. Watch that video, and then I'll have like 5 problems for you to try on your own. Let me know if you have any questions. Please remember to email me questions or come to office hours. I would love to help you out, talk to you, talk you through it. I have Skype. So anyways, have a great day, guys, and I hope you rock it out on your acceleration test coming up Friday. Have a good day.